your drive. If it's connected, it should look like this. The icon for the drive with a slash. Then let me share the data. This is the data I'm going to share with you. I put it in your GDev group for now. Yeah, this is the data. So, okay. This one. Yeah, this is the data I'm about to share with you. Hope now you can get it. Then we go back to our Google Collaboratory. Hope you can see my screen. Yeah. So on your drive, you have to import the data on your Google Drive. So hope your interface looks like this. So what will you do? You will come to the icon for the Google Drive, that icon. Then it will pop up a message saying permit this notebook to access your Google Drive files. Then you connect to your Google Drive. So mine have already accessed the Google Drive. For those one whose the drive has not imported, are you familiar with how we import the data in your drive, the Google Drive? So let me take you that process. We come here. Enter in your drive. Let me share. Can you see this interface? Yeah. This is my drive. I had pulled these files, the pandas for beginner copy of pandas. So if you have those files, then you come here and import your data to your drive. You click new, then file upload. Then you locate where you have saved your data that you have downloaded from the group. Mine I stored it there on the data. So according to your respective places where you had stored the groups, you can select your file, the sales one. You select the sales, then open. One upload complete, which means my data is already uploaded. That's the process of importing your data to your drive. Yeah. Then we go back to our Google Colab. Google Colab. You can see mine have already the drive and connected it. This is the sale data that I imported. Hope yours looks like this. Okay. No need to install again my Panda. Then we can go back to the coding interface. I don't need to install mine since I already installed earlier. So what you do, the code that you wrote, import pandas as PD, you can learn it so that you'll have that many pandas in your Colab activated. So now then, hope you have already activated by running the icon on the left of your import pandas PD. Then we shall have to read we read our file using pandas. Okay. This is my data that I wrote in on my drive. You come here on your sales CSV, right click, then copy path. I've already copied my path. So this path of ours, we have to give it a variable data. We give it a variable data is equal to pd dot read CSV. Since our file is a CSV, inside it we shall paste our path. Is it working? Have you pasted your path inside there? In between the parentheses? Okay, then we'll have to run our code so that we can read our data using that variable. You see a green tick on your left side when it have run successfully. Then we shall have to read our data. Python is very easy since you don't have to write the data type of your data. You just write the name of the variable. Then you run the cell, run that cell. Mine looks like this. Hope yours looks like this. Okay. The same as this. So the next thing we shall do, you write this code, data.head10. This means that we get the first 10 rows of your data. Data.head, inside the parentheses, you shall write 10, meaning that you shall read the first 10 rows of your data, including the headings of your columns. But in default, it normally reads without any value inside the parentheses. It normally reads the first five columns. Yeah. Hope it have worked. Then to get the last 10 columns, you just type your variable data.tail10. Head means you are starting from the top of your data frame, but tail means that you are starting from down below. To know the number of rows and columns in your data, you just write your variable data.shape, you get the number of your rows and columns. According to our data frame, we have 4,240 rows. 4,240, but it is 4,241 since it starts from 0. Okay, then after getting the number of rows and columns in your data, you can, if you want to know the type of your variable it is, you just type inside the parentheses, put your variable data. it will give you an output of pandas.core.frame.dataframe, which means our data is a data frame, which is the main data structure in pandas together with the series. The data frame is our table that we generated using our variable. So then, to know the data type in our data frame, you shall just write data.info, which means data information. You'll get your data type. Remember, the data is the table, the data frame, or the table that we generated using our variable. The next thing is yeah. Yeah. I can see you're asking, can I repeat the upload? Yeah. Let me repeat again on how we upload the file. So can you see the window? My uploading file window. Yeah. You come on this. The drive app is on the other side of your Chrome browser. There's this part called the driver. I think is this one. It is called the drive. Then to upload, you shall click on the new icon. The new icon. You'll see another small window that have popped out on our site, whereby you will click on the file upload. After that, navigate to where you have saved your data. Just click on the data, then open. When you have clicked, mine had installed in a folder called complete Geopandas course. Then you can, because I don't want to interfere, yours you shall just upload. Mine, I don't want to confuse it since I'm working with it right now. After that process, hope you get your data saved on your drive. Mine is my drive. These are all the data that I have ever uploaded. So to continue with it, where we left was on data.describe. Can you see my window? Yeah. So on data.describe, you get the statistical information of your data. Whereby you will get the count, the mean, the count of the sale, the profit, marketing, the mean of all your columns, the standard deviation of all your columns, the minimum values of all your columns, 25, the percentiles for your columns, and the maximum values of your columns. So, since that was the data we had already used, I would have shown you on how to convert a list and a dictionary into a data frame. You can write a simple list like this. This is a Python list. This is equal to square brackets. Inside it, you write ants, cricket, and bee. And to confirm that that's a list, you can just type the method type inside, put your variable insects. So mine is red, giving me error because I have not already run my mine. But you can see it is giving us a message that it is a list. After that, you can convert your list to a data frame. So you give a variable to your new data frame that you want to create. Name it data underscore insects or any variable that suits to you. So then to create a data frame, we shall use pandas. That's why I said we import the pandas. So we imported pandas as PD. We then try to run your data. I don't know why mine is giving. Yeah. Yeah, they have generated a data frame. After that, then we shall deal with the dictionaries. For dictionaries, it's quite simple since you have to give the curly braces. Animals inside the dictionary normally have the curly braces, where inside it you put your data. You shall describe your data. The first thing we shall start with the head of our data frame, the mammals. For example, the mammals, the, then followed by a list with this sign. After this, followed by a list, you can name you can give your data as many as you want inside this list. Remember, the data that you give in the list should be the same. For example, in mine we have the cow, sheep, and lion. They are three. The reptiles have crocodile, lizard, and snake. They are three. And insects, we have ant, cricket, and bee. They are three. Immediately after writing your headers for the list, then you can type the type of animals after you have done it. Later on, you can you can create your data frame. This is simple. That's why I say this is data underscore animals. That's our variable where we have our data frame. So pd.dataframe animals. Then you shall run your code after you have written your data underscore animals variable. Yeah, that was just an introduction. Then we can, if you want to select a certain column on your data frame, you shall first proceed with the variable, then square brackets. Inside it, write the header of your data frame or your table. Write the header of your data frame. After running it, it will give you the items that are in that column. In our case, we have the mammals, we have the cow, sheep, and lion. So next, there's also another method of getting our columns by writing just our variable. After it, you give a full stop, then you add the head of your column. For example, yeah.
Someone has a question?
Yes. Consequence.
Oh, ameondoka.
Direct.
Ni kama ameondoka kwa meeting.
Oh, yeah. Then we can continue. The other way of accessing our head of the data is through our variable, then full stop. Then you can give your head of your data frame. For example, the reptiles. The reptiles have the crocodile, lizard, and snake. And after running it, we shall get crocodile, lizard, and snake, of which it have run. Then inside every column, remember we always have the series. Inside every column, we have the series. And the series contains the ant, cricket, and bee. So for example, in our reptiles column, we have the crocodile, lizard, and snake. And if you just run your cell after writing that code, you get something like it's a series. Type is used to check the type of the variable you have just written. So to access your rows, you can use this code, the IROC. The IROC means index location. For example, I wanted to locate my row with the index 0, of which is crocodile, cow, crocodile, and ant. To come to get the type of what you have accessed using the index, we also find that even the rows are telling us that even the rows are also series. Which means the reason why I had to start with this is that how we define our data frame. Our data frame is a combination of series. Either the column or the row is a series. So this was my. Then we can go back to our data. To get your data, you can, on the next side, you can just type data. Type data.head, it will give you the first five rows. So after that, you can get the index location of your form. Mine had already interfered it, so we might not get the indexes, but on your part, the indexes must appear. So to locate your data frame with which have the data. For example, my head, maybe you have in our data frame we have various states. On the states column, we have the California. We have the California and other states. But I had only to locate the states which have the California. So since I have set my index to state, so this code was had set my data frame to have the keys as state. So that we can avoid using the indexes column while accessing. So using our indexes state, you can use the log. For the indexes, we use the IROC, but for the state, as the index, we use the log. So after that, you can select your California states by writing inside the log California. The next thing is the log for Colorado. So I locate my rows with the Colorado state in the Colorado state of which they appear. Yeah. That was just a brief introduction. So I think if I can just go through my geopandas of which was our main agenda of the meeting. So time might not let us have that time to install the Conda. Hope you have them. The Anaconda. Do you have Anaconda installed? So at the GDev group, I had shared a Python file which contains my code. Have you seen it? Yeah, I had already sent in the group. Can you see anything? Yeah.
They are confirming.
Yeah. Yeah, that's fine. So that's the use of the Jupyter notebook. So it might take a long time to install it, but I send a PDF later on how to install the Anaconda, which is a package which contains all the libraries, all the Jupyter, the Spider, the PyCharm, and all other things. Okay, now let me explain on Geopandas. Geopandas is an extended library of pandas which is able to handle the spatial data. So to handle spatial data, you have to use some libraries. The first library is the Geopandas. You have the matplotlib for plotting. So, for example, the matplotlib had used it to plot a certain Nyeri County here. Hope to have the base map with a base map. Hope you can see that output. To have the northings, eastings, the title, and how we can modify since if we would not have modified our label data, our labels, there would be a collapse in the values on this site. To avoid that, I had to modify them using the rotation. Let me show you. The rotation, I had put the rotation 90. But now let's start with it. An overview. Okay. So you have first to import pandas. If it's not imported, if it's not installed, you have to write this code here. First, pip install pandas. Then it will give you an output like this to confirm that you have installed it. Then, since we need these two libraries, even the matplotlib, you can come here and install matplotlib. Yeah, can you see it? So then we shall have to import the matplotlib and the geopandas, and imported my matplotlib here. Then I have imported my geopandas here. So since geopandas works as well like the pandas, it works the same as the pandas. So subcounty is equal to gpd dot. So subcounty is equal to geopandas dot read file. Then read file, how I have read it is through accessing my folder, copied the path, then I pasted here. And before pasting, you shall have to write the R, which means read your path. So I might be a bit fast to complete the presentation. We can get the coordinate system of our sub-counties since it's their data that I uploaded. To get the coordinate system, you shall write this called your sub-counties variable, then dot CRS, which means coordinate reference system. The coordinate reference system of our sub-counties was geographic coordinate system, of which was 4326. This is the description of the coordinate system. You can also transform your coordinate system from one coordinate system to another by just writing after the sub-counties. You just have to write .to CRS. Inside it, write the code of your projection. The 21037 is a UTM coordinate system, the projected coordinate system for our counties or Kenya, mostly on the southern part. After that, then we can check whether we have transformed our data. After learning the cell, you can see that we have gotten our coordinate system have already been transformed to EPSG 21037 with all the attributes of each, including the name Act 1916-37 South. Immediately after that, we have the sub-counties. We can check the area. We can calculate the area using Geopandas, which is just simple. Just writing the sub-counties dot area, you get the area for the sub-counties. But first you have to give another column named area on this side. Then you write sub-counties dot area to calculate our areas and give them in our data frame. Yeah. After that, you can see my first 4 counties, and that's why I had introduced you on the pandas. You can see to read the first 4 counties, I can use dotted inside it. I put 4. You can see the area side here. So immediately after that, you can read multiple files. You can also read the reverse file, which is this one. Let me just run. Just type the pandas. The Geopandas. You can see I've read my Kenya rivers. You can also plot these Kenya rivers. To plot them, you just have to write the variable Kenya rivers. Kenya rivers. Inside the Kenya rivers, you just have to write dot plot. Then run. You can see our Kenya rivers have already been plotted. So after that, you can select your sub-counties using the location that I shown in pandas, the location type. Sub-counties, of which our sub-counties were the sub-counties of Kenya. We have already run. So after we have plotted, we can get the 5th row of our data. You can see our 5th row, the data on our 5th row, the country is Kenya, the provision of the code. Remember this data is coming from our geodata frame. This way, for dealing the spatial data, we call it geodata frame because of maybe it is able to handle the geometric data, of which it have the geometric data, but it's not the same as the other one, where we had know the geometry. That's the essence of the Geopandas to the mapping industries. As well as Python, there are many libraries for doing it. We can get the first 5. You can see we have the geometry column, the area that I had calculated using the variable dot area. You can see the country, province, and the rest. This was just a code to access my color map. But what is important to us, we may want to get our sub-counties which are in western areas. So how do we get them? You can come here, just give western. Inside the variable, you can just write this called sub-counties inside the square bracket, just write sub-counties province is equal to Western. In Python, we don't just write the equal sign once, we write it twice. We can also plot the Western counties. Let us first stop. But first, before plotting, you can also get if you want to know the counties that are in Western, you can just type .unique. You get the unique values of our counties. Then you can plot your Western counties, western.plot. After that, you can see that we have our Western counties plotted. Then we may want to plot our areas of the Western counties. We may want to plot our bases of the Western counties. The Western counties on a pie chart. So how do you do it? You just have first to sort our values from the country with the largest area to that with the lowest. That's why I have kept it as ascending is equal to false, which means it will be descending from the highest to the lowest. You just have to write the variable your Western dot sort values. You sort them by. If you don't give the by, it will not do anything, but you have to specify what you want to plot, what you want to sort. So mine, I wanted to sort the area to know which county on a pie chart. So after that, I can get my county Kakamega. So let me see if we have any question. After that, you can see that we have just extracted our county Kakamega. So our aim is to give a pie chart of our Kakamega sub-counties. First, you have to get the labels. The labels, how you get the labels? You shall have to write your suitable variables for getting the labels, and the labels are from the sub-county part. Since the sub-county part is the one that contains the names of your sub-county. For example, here you can see Mvita sub-county, Kisumu Central, 2US, and things like that. To plot our pie chart for Kakamega, you just have to write plt.py, which means the plt means matplotlib.pyplot, of which we gave it a name as plt. So plt.py, inside it you give Kakamega, of which is the variable we are doing is, since we want to get the pie chart for the areas of the Kakamega according to the sub-counties in Kakamega. And that's how we get the pie chart with its responsible labels. But if in case you may want to name your labels, you might find an error, since getting these labels, you may not be sure of where you are provisioning these labels can come right pie chart. So the best thing is to do this, just get the labels using the sub-county column. After that, you can set the index. Instead of having the index starting from 0, but on my case, I already interfered with it, and the set index as county, whereby my index is no longer a value, but the county header. So after that, You set your index is equal to count, then it will give you a data frame like this. Later on, I can choose my unique counties. For example, now since we have just dealt with the Western, now we can get the central province counties, and I used a very unique code. It is called the county P code. I just give the P codes for the country. For example, for Nyeri is 219, Ken 219. So I got it. Ken 219 for Nyandarua is 18, Kiambu 22, Moranga 21, and Kirinyaga 20. So to get these value, the unique values, you must write the central province inside, give the square brackets. Inside the square brackets, we can have our variable central province, then you give the column you want to select with. Dot esin means that you get those. You just have to use these codes, these P codes to get our data. So then we can have our data frame by running this cell 17, and they already run it. Then you can get the unique counties again, where it is Nyeri. For now, we want to get the Nyeri sub-counties. So I gave them a variable A to get the Nyeri sub-counties, whereby I said unique counties. Our unique counties are these. I had selected them here. I share this Python file. After that, you can select your county is equal to Nyeri. You can also sort our values. Then we can draw a pie chart for it. At first, we have to sort our values. You have to sort our values according to area, and ascending should be false, meaning should be descending. Or according to your preference, you can also start with ascending is equal to true to be ascending. Later on, you can plot just the same way we had plot the other one. According to this one, you can see that Kieni East Sub-County and Kieni West Sub-Counties had the largest areas of the Nyeri sub-counties. The one with the lowest was Mathira, Mukureni, and Nyeri Central. So this was just getting a copy of my river so that I can't interfere them. So that you cannot interfere them, you can copy them. Using .copy, then you can plot your data. You can just plot your data using .plot function or method. You can get your CRS coordinate reference system. To know your coordinate reference system of your rivers, you just have to type kenyariver.crs, you get your coordinate reference system. You can also reproject the same way as we did the other one. You can reproject your coordinate reference system by just typing .to_crs, then give the code of your coordinate system. Later on, you can plot I want you to see the difference. According to using our coordinate UTM zone 37 south, you can see that we have some values here. There's no negative values, but on the other one, when we had not transformed our data, we had not done coordinate transformation, we had some negative values here. But after we have transformed it, you can see that we have some very good values, especially on our X-ray balls. We can see have 200,000 on the eastings. The other thing you can do with Geopandas, you can scrape your data using Kenya River.plot. Then you just have to give the river you have to overlay the data. gpd.overlay Kenya rivers projects. This is our data, the Kenya rivers. Then the next variable that follows the Kenya rivers is Nyeri, which means I want Nyeri to define the boundaries of the rivers I want. By how, it means I want them to have an intercept. So, for example, where these links share an area, that's where the Kenya rivers will be selected. Then you can plot our Nyeri rivers. You can see Nyeri have some rivers, not some, but there are many. You can define the line width. For example, in the other data, you can see that our line width was very thick. You see, but you can make them as sharp as you want. I gave them a value of 0.3. For my data, I gave them a value of 0.5. You can see our Nyeri rivers. Later on, we can just plot both our data. For example, in this code, you have used matplotlib, but now I want to show you how to plot multiple data on the same data frame. The first thing, you have to write this code, fig axis, which means these are axes. In our case, we just want to use the same axis to plot multiple data. So you put plt.subplots. Then you can plot our data nyeri.plot, just the same as the other. The axis should be AX, axis is AX, figure size should be 5 by 5, edge color can be black, which means this is the boundary colors. The face color is none. So you can see our title Nyeri. I can give my, okay, at this point I show how to plot in a very brief manner. So after plotting the Nyeri rivers on the same axis, you can see Nyeri was plotted on the axis AX. The same way we have plotted the Kenya rivers on the axis AX. We also have another way of plotting the data from using object-oriented, but I not show you for now. That's maybe for the next time I do it. So I gave my data frame, I gave my plot a title Nyeri. I set the X rainbow, which means the X values eastings, Y values northings. Then I gave my region. I tried to give my region, but it was not okay. I don't know what, but I show you later how we do it. So the other thing we can do is you can do is to rotate our values. Maybe this value